All right, so these ones are solving absolute value inequalities, and in fact, if you look at the Alex explanation, they're going to tell you two different ways to do it depending on whether this is a greater than or a less than sign. Absolute value, remember, is a distance. If it's greater than, you're more than 6 places away from wherever the middle of this is, and it ends up being an or problem. I'm going this way or this way. If it's a less than, I'm less than 6 places from the middle, and it ends up being an and, where I'm between the two numbers. Well, you could remember that, or you can just do this. We're doing an absolute value problem. We know we're going to have the two cases, like they like to call them. The first one is the exact same problem. So 4x minus 2 is greater than 6. The second one, when you do the negative, you're just going to reverse your inequality symbol. So the 4x minus 2 will stay the same, but instead of being greater than 6, we're going to do is less than negative 6. And then you just solve them like you normally solve everything else. So I would add my 2, 4x is greater than 8, and divide by 4, so x is greater than 2. Same thing on the other one. I'm going to add my 2, 4x would be less than negative 4, divide by 4, x is less than negative 1. Then you're just going to graph it. You don't really have to worry about if it's an and or an or, if you just follow your answers there. So x is greater than 2, I have an open circle around the 2. X is less than negative 1, I have an open circle around the negative 1. Greater than the 2, less than the negative 1. And you can see that, oh, yep, it ended up being the opposite directions, since it should, since it's a greater than. So again, on this one, I don't really worry about if it's going to be an and or an or. I know it is an and, but I just say, okay, 6x plus 9 is less than or equal to 15, which is my original problem without the absolute value. And then I do the 6x plus 9 and switch my sign, so greater than or equal to negative 15. Question?
My problem's different.
It is.
Yeah, I have 3x plus 14 is less than or equal to 5.
Which one is the one that's not going to work out right? 6. Well, let's work this one out and then we'll check. Other people type these for me, then I have them on a flash drive and this and that, and then I get in class and the problem doesn't work out right and I change it, but I didn't get changed everywhere. So I may have made the wrong copy. We'll find out. So if we solve this one, we're going to subtract our 9. So we're going to get 6x is less than or equal to 6. And if I divide by 6, x is less than or equal to 1, right? On the other one, if we subtract our 9, 6x would be greater than or equal to negative 24. And if I divide by 6, x is greater than or, 6. I was thinking I had to flip it, but I have to divide by 6. X is greater than or equal to negative 4. Let's see, on that one, if I subtracted my 14, I was just trying to see if it comes out to a weird answer. Upside down. 5 minus 14 divided by 3, that comes out okay. And it would be negative 5 minus 14. No, that comes out to 19. Yeah, I probably copied the wrong paper. Switch it to this problem because it comes out right. Otherwise it comes out to a fraction, and yeah, none of them on Alex will. So we will have a filled in dot on the 1. We will have a filled in dot on the negative 4. We are less than 1, greater than the negative 4, so we end up shading between the two dots. write myself a note. So I get the right one in the packet. All right, so number 3, do you have the same one there, or is that different?
That's
Okay, so this one must have worked out right. My 2 problems then, if I'm going to solve this one, would be what?
negative 2x plus 7 is greater than or equal to 3.
And?
Negative 2x plus 7 is less than or equal to negative 3.
Exactly. So the original problem, and then flipping my sign, doing the negative. So solving that, if I solve that, I would minus my 7, and I get
Negative 4.
negative 2x is greater than or equal to negative 4. When I divide by negative 2, I would get
X is less than or equal to 2.
x is less than or equal to 2, because I divided by a negative, I have to flip my sign. On the other one, again, I'm going to minus my 7, so negative 2x is less than or equal to negative 10. And when I divide by negative 2, my answer is
X is greater than or equal to 5.
x is greater than or equal to 5. So our end marks, we have filled in dots at 2 and 5. I am less than the 2, greater than or equal to the 5, and so you can see, yep, it ended up going in the 2 opposite directions like it should, because there was a greater than to begin with up there. So 4, 5, and 6 are just expanding on that. So they're going to have you isolate the absolute value first, and then you can use that exact same rule we just used on the previous ones to come up with your answer. So if I'm going to solve this, I want to get the absolute value by itself. I'm going to minus the 7 to move that over to the other side. 6 times the absolute value of w minus 4 is less than 12 then. I'm then going to get rid of the coefficient by dividing by the 6. So the absolute value of w minus 4 is less than 2. Now that looks just like the previous problems we did, or at least similar to the previous problems we did. W minus 4 is less than 2. W minus 4 is greater than negative 2. Doing my 2 problems. So if I solve those, I'm going to add my 4 on both of them. W is less than 6. W is greater than 2. Now in these ones, you're not going to graph them, but you either have to connect them with the word and or the word or. And so I want to think about it. If I'm less than 6 and greater than 2, am I going in the 2 opposite directions, or am I between the 2 numbers? Between the 2 numbers. I could put it like this and just put the word and in between. It's perfectly acceptable to do. If it is an and one, they're going to rewrite it as a compound inequality where the 2 is less than the w, which is less than 6. 6 are the w's between the 2 and the 6, right? Doesn't matter, you can put it in either way. If you put it in this way, it'll just say it's correct, however, you could have written it this way. Or you have to put it in the long way. So number 5, if I want to solve that, the first thing I should do is subtract my 22. So the absolute value of 5y is greater than or equal to 6, right? So on this one, the absolute value is by itself. I'm already going to hop over and do my 2 problems then. Either the 5y is greater than or equal to 6, or 5y is less than or equal to my negative 6. And then we just solve those. So all we need to do is divide by 5. Y is greater than or equal to 6/5. Y is less than or equal to negative 6/5. And would that be connected with an and or an or? greater than the positive, less than the negative, so I'm going two opposite directions if I put them on my number line. So it's going to be an OR. Number 6, if we're going to solve that one, first thing we're going to do, subtract our 3. So 2 times the absolute value of u plus 8 is less than negative 20. We're then going to divide by 2. Absolute value of u plus 8 is less than negative 10. Now, these ones are kind of weird. Because we're talking about a distance, can my distance be less than a negative number? No. So this one's going to be no solution. If this would have been a greater than, can a distance be greater than a negative number? It always is, right? Then you have the all real numbers are solutions answer. So if this is a less than, you get no solution, but if it would have been a greater than a negative, you would have had all real numbers. These ones, they're solving where we have the variable in the denominator of our fraction. And so the first thing they're always going to do is get rid of the fractions, like they did with the numbers anyway, in most cases. But they're going to multiply by the denominator to get rid of the fractions. They're going to start with some really basic ones and then get a little longer as we go. So we're going to multiply both sides by y, so we can cancel our fraction. Negative 8y equals negative 4. We're going to divide by our negative 8 and simplify our fraction. Negative over a negative makes it a positive, and 4/8 reduces down to 1/2. You guys probably already got all these right on your pie chart. So number 8, first thing you do,
multiply by x.
Multiply by x, and I would have 9x equals negative 6. I'm going to divide by 9, so my answer is the girls are sleeping back there. Veda? Negative 2/3. So number 9, if we're going to solve that, we're going to, it goes faster if you talk, multiply by w. I'm going to have 8 equals 6w. It's going to be one of these days. And then I have to divide by my 6, and so my answer is w equals 4/3. Ten, 11, 12, same philosophy behind there. I want to get rid of the fraction. I have to multiply by the denominator. The denominator says w plus 5. And so when I multiply by the denominator, I can cancel out my fraction, and I'm going to use my distributive property over there. So 1 is going to equal negative 5w minus 25. And then I solve my equation just like I solve every other equation. I'm going to add my 25. So 26 equals negative 5w, and divide by my negative 5. Of course, they like the negative out in front. So w is going to equal negative 26/5. So number 11, if I want to solve that, I'm going to start by
using the denominator.
Multiplying by my denominator of v minus 1. So I can cancel my fraction, and then I would have 5 equals negative 3b plus 3 when I distribute that out. I'm then going to subtract my 3. 2 equals negative 3v, and then divide, and my answer is negative 2/3. I'm glad you're here today, Gavin. So number 12, if I'm going to solve that one, when I multiply by my u plus 6, I'm then going to get what?
Negative 4u minus 24 equals negative 1.
Negative 4u minus 24 equals negative 1. From there, I'm going to
24.
add my 24. So negative 4u equals 23. And then I'm going to I know you guys know how to do these. U equals negative 23/4 then. The next one, solving rational equations that simplify into linear equations. Same kind of philosophy. I want to get rid of the fractions, so I'm multiplying by my common denominator. In this one I have a 3 and an x, so I have to multiply every term by the 3x. One to get rid of the 3 and one to get rid of the x. So if I take that times 3x, this one times 3x, and this one times 3x. Here I didn't have a fraction, I'm just going to multiply. 3x times 2 is 6x. Here I'm going to just cancel out the 3's. So 4 times x is 4x. Here I'm going to cancel out the x's. So negative 5 times 3 is minus 15. And then I go ahead and solve my equation. So I'm going to minus my 4x. 2x is going to equal negative 15. And of course divide by my coefficient of 2. So x is equal to negative 15/2. So number 14, if I'm going to multiply by my common denominator, I'm going to multiply by x. Since they're the same thing, I don't have to multiply by x squared. I can just multiply by a plain x, just like if they were both 2's. And so if I multiply by x, I'm then going to have
2 equals 10 minus 3x.
2 equals 10 minus 3x. If I'm going to solve that, I would subtract my 10. Negative 8 equals negative 3x. And when I divide, my answer is going to be
X equals 8/3.
x equals 8/3. And on the third one, my denominator is c. So I'm going to multiply everything times c. And so when I do that, I'm going to get
2c plus 21 equals 5c.
2c plus 21 equals 5c. So solving that, I'd probably subtract my 2c first, right? 21 equals 3c, and when I divide, my answer is c equals 7. All right, they did all those really simple ones so they could get to something that was maybe a little more challenging than those previous ones. Same philosophy here. I want to get rid of my fractions by multiplying by the common denominator. I want to recognize here that I could factor out the 3, and this would be 3 times y minus 3. So the y minus 3 is here. I have to use both the 3 and the y minus 3 to cancel out my fractions. So 3 times y minus 3, 3 times y minus 3, and 3 times y minus 3. Here my y minus 3 is going to cancel out. So 3 times negative 7 will be negative 21. Now here, hopefully you recognize that the 3 times y minus 3 is the same thing as the 3y minus 9, so the whole thing's going to cancel out. Don't forget the negative in front, so I'm going to have a minus 8 there. Here, I'm going to multiply this out. I actually just look at this one, because if I multiplied that back out, it'd still be 3y minus 9, so I would have minus 12y and a positive 36 when I take that negative 4 times that denominator down there. You could take the negative 4 times the 3 and then multiply negative 12 times your parentheses. You get the same thing. So if I'm going to solve that one, what should I do?
Combine like terms.
So negative 21 is going to equal, and on the right side I'm going to get
Negative 12y plus 28.
negative 12y plus 28. I'm then going to subtract the 28, so I get negative 49 equals negative 12y, and when I divide, my answer then is y equals 49/12. Man, you guys are so excited today. I think those girls are sleeping back there. So usually, instead of putting it in factored form, because I realize over on this side I don't really need it factored, when I multiply by my common denominator, I would multiply by 3u plus 15, 3u plus 15, and the only place I'd probably really factor it is there. 3 times u plus 5 is the same thing as 3 times u plus 15. So, canceling out my fraction on that side, on the left-hand side, what am I going to get? We're just going to look at their papers and pretend that I don't know they're here. Emily, what you get?
What are you asking? 3? 15?
If I do this left side of my equation, what am I going to have?
I got, let's see, 5 plus 6 times u plus 5.
Plus what on the end?
Mine was in parentheses. I still did it differently.
Oh, we'll keep going.
Well, I got 5, and then equals
So if you do the 6 times the 5, you're going to have 30, right? Equals, on the other side, I'm going to get
negative 21.
negative 21. So she took the 2 times the 3 and had 6 times u plus 5, and then took the 6 times the u plus 5 and got 6u plus 30. Combining my like terms then, 6u plus 35 equals negative 21. Subtracting my 35, I would get 6u equals
Negative 56.
negative 56, and when I divide by 6 and reduce my fraction down, my answer is going to be so negative 28 thirds, right? Since I have a negative over a positive, I'm going to stay negative. So number 18, same kind of thing. I'm going to multiply by my common denominator. My common denominator would be
4b minus 24.
4v minus 24. So 4v minus 24, 4v minus 24, and then over here I'm going to write it as 4 times v minus 6 and put it in factored form since I don't have that whole thing in the denominator. So canceling there, on the left side I'm going to end up with what?
8 minus 4b plus 24.
8 minus 4v plus 24 equals, on the other side I'm going to get 8. So what's the next thing you want to do solving that?
Combine like terms.
Combine my like terms. Negative 4v plus 32 equals 8 then. And then I'm going to
Subtract 32.
subtract my 32. Negative 4v equals negative 24. And then I'm going to divide, and my answer is going to be 6, right?
That doesn't work out.
It doesn't work out?
Because you could put B6 back in.
Oh, criminies, I forgot I should have been checking my answers. Good thing you're paying attention. Notice up there it says if there's no solution, click on no solution. If we check this one back out and we put the 6 in here, I get 6 minus 6 on the bottom, which is 0. 2 divided by 0 is undefined. So I better not put v equals 6. I better put no solution. I should really read the directions and then remind me what I'm doing. So all of those, in theory, I probably should have been checking, but I think that's the only one that came out to no solution. Then 19, 20, and 21, they go back to that algebraic symbol manipulation thing where I'm solving in terms of another variable. Since they're working with these fraction ones, that's what they think your first step is going to be, is getting rid of the fraction by multiplying by the denominator. So on this first one, they would multiply by the I and say IR equals E. And then they want to solve it for I, so they have to get rid of the R by dividing. And so I equals E over R. So number 20. If I'm going to solve that one, the first thing they're going to do is multiply by the t. So I equals PRT. If I'm going to solve that one for t, I'm going to divide by the p and the r. And so t is going to equal I over PR. And number 21, you could multiply by the denominator FA, or you could just think of it as a proportion and cross multiply. Either way, you get the same thing. And so, what do you want to do with that one?
Proportion.
Proportion, so if I cross multiply, I'm going to get
AM equals 6F.
AM equals 6F. And I want to solve it for A, so I'm going to divide by the M. A equals 6F over M, then is going to be my answer. And then the next ones, they just made it a little longer, or think they made it a little harder. Same thing. Whatever's in the denominator, they're going to multiply by first, whether they're solving for that or not. So they're going to go ahead and multiply by the p and the r plus s. So they're going to have np times r plus s equals L for their first step. I want to solve it for the s, so the next thing I might want to do is
Divide by.
divide by the np. And so R plus S equals L over NP. And then I'm going to move my R to the other side by subtracting. So S is going to equal L over NP minus R. So number 23, first thing I'm going to do is
Times by C plus D.
times by the C plus D. So A times C plus D is going to equal B plus 4. You could use your distributive property, but you really don't need to. Since I'm solving it for the D, the next thing I might want to do is divide by the A. So C plus D equals B plus 4 all over A. And then I would
Subtract C.
subtract the C. So D is going to equal B plus 4 over A minus the C. So number 24, first thing I'd want to do is
Times by S.
times by the S. So 6 times R sub 1 minus R sub 2 equals AS. Then I would
Divide by 6.
divide by my 6. So R sub 1 minus R sub 2 equals AS over 6. From there I would
Subtract R1.
subtract my R sub 1. So negative R sub 2 equals AS over 6 minus R sub 1. And then I would have to divide by negative 1, which just basically changes all of my signs. So R sub 2 is going to equal negative AS over 6 plus R sub 1. And if you wanted to switch the order of that, you could, but you don't really have to. It just looks prettier the other way. Word problem involving multiple rates. There are a couple different ways you could do this problem. On the ALEX program, they're just going to find the rate of each machine separately and then divide by that rate together. So it says if there's 2 machines that produce aluminum cans, the newer machine can produce 5,400 cans in 180 minutes. So if we take the 5,400 and divide it by 180, we would get 30. So the first one does 30 cans per minute. The older machine takes 270 minutes to produce that many cans. So it's still doing 5,400 cans, but it's taking 270 minutes. So how many cans per minute does that machine do? 20? 20. So if the first one's doing 30 cans per minute, the second one's doing 20 cans per minute, if they work together, obviously they're going to do 50 cans per minute. They're still going to do 5,400 cans at a rate of 50 cans per minute. So if we take the 5,400 and we divide it by the 50, how many minutes does it take them together?
108.
108 minutes. So the first one took 180, the second one took 270. They work together, obviously it should take them less time. It only takes them 108 minutes. So that's the way they're going to go about solving these. So a swimming pool holds 540,000 liters of water. It has 2 drainage pipes. When the pool is completely full, the first pipe alone can empty it in 150 minutes. So if we take our 540,000, divide it by our 150 minutes, how many liters per minute does it pump out?
3,600.
3,600? The second pipe alone can empty it in 225 minutes. So if we take our 540,000, divide it by our 225, how many liters per minute does that one pump out? 2,400. So if they work together, how many liters together can they pump out? 6,000, right? And so if we take 5,400 and divide it by 6,000, we get 90. In 90 minutes then. So the first one can empty it in 150, the second one in 225. If they work together, only going to take them 90 minutes. And the last one, there are 720 dishes that need to be rinsed. John can rinse them in 120 minutes by himself. It will take his friend Bob 72 minutes to rinse them by himself. How long will it take them if they rinse these 720 dishes together? So John takes 120 minutes to rinse off 720 dishes. How many dishes per minute does he rinse? 6. Bob only takes 72 minutes. So that means he's rinsing off 10 dishes every minute, right? So if they work together, they can rinse 16 dishes per minute. They have 720 dishes to rinse at a rate of 16 of them every minute. How many minutes is it going to take them? 40 what?
45.
45 minutes. All right, that should be the next 9 or so topics on your pie chart, unless you already knew how to